With this lesson, we very much pick up exactly where lesson 36 left off. Where at the very end of lesson 36, we were working with taking like an expression like sine to the 6x plus sine squared x, and we wanted to write it in terms of tangent only or in terms of cosine only. Well, with this lesson, we're picking up right there. But before we go and get started with one of our first examples, I just really quickly wrote out at the start of this notes. It wanted you to write down as many identities as you could. So I kind of just wrote down what I was anticipating y'all to hopefully write. The basic things like sine times its inverse, which is cosecant, always is 1. Cosine times its inverse is 1. Tangent times its inverse is 1. And then, of course, tangents are y over x or sine over cosine and vice versa. And it's always good to remember that you can always rearrange these things. So like cosecant is the same thing as 1 divided by sine. Secant is the reciprocal, 1 over cosine. Cotangent's 1 over tangent. So here, those left columns, the left two columns here in green, are basically just how you use, I guess, properties or identities when they're all to the first power. And then the properties that we have dealing with only squares, and that these only work if you have them squared, are these three right here, with the most popular being sine squared plus cosine squared equals 1. And then the derivatives or just getting the simplifications or rearranging of them, you'll get tangent squared plus 1 is secant squared, and cotangent plus 1 equals cosecant squared. So this does not work if they were cubes. It doesn't work if they were to the first power. This only works specifically for squares. Okay, well, let's get over to our first example. We're going to use these. And in our first example, here's the difference. If I started to look here on the left, okay, we have 3 secant to the 4th x minus 2 tangent squared x. And in the end of lesson 36, it would say write this in terms of, let's say, cosine only. Well, here we actually have a definite answer we're trying to get to. Our goal is to get this left side to eventually be this right side. And we don't know, we have to try all of our different identities that we wrote before to try to get to there. Okay? So the first thing I'm going to notice is that on my left, I have the trig function secant and tangent, and on the right I have the trig function all tangents. Okay, so my first reaction is I'm probably going to leave the tangent over here on this term, and I need to replace this secant to the 4th x. So do we have an identity where I can take away secant to the 4th and leave behind a tangent? Well, none of my identities have to do with the 4th power, but my identities either are the first power or the second power. And let's rewrite that as 3 times secant squared x times secant squared x, and then minus the 2 tangent squared x. And I'm just going to leave the right side open, because all we're going to do is manipulate the left side, eventually trying to get to the right side. Okay? And then each of these secant squareds, we have an identity that we can use. Let me think. What is that identity that involves both secant and tangent? Well, over here on the right, I'll write it out. It says tangent squared x plus 1 is equal to secant squared x. Okay, so I'm going to come over here, and everywhere I see a secant squared x, I'm going to replace it with tangent squared x plus 1. So it'll be 3 times tangent squared x plus 1 times tangent squared x plus 1 minus 2 tangent squared x. Okay, and from there we're looking good. We're all in terms of tangents. Let's see where we can get with this. So let me FOIL those two together. You'll get tangent to the 4th x. Outsides and insides, you get a tangent squared, another tangent squared, so a total of 2 of the tangent squared x's, and then plus 1 minus 2 tangent squared x. Okay, distribute the 3 inside, so 3 tangent to the 4th x plus 6 tangent squared x plus 3 minus 2 tangent squared x. And finishing up, combining all of our like terms, we have 3 tangent to the 4th, got 6, but I'm going to subtract off 2, so a total of a positive 4 tangent squared x and plus 3. And if we look where we're trying to get to, it looks like we got it, so I'm going to check it off. So when you get to a problem like this and you're like, okay, what's my answer? You're not going to really circle your answer, because your answer is all of this right here. Your answer is showing me the steps on what you would do to get from the left side over to the right side. Okay, so let's try this again. Let's go over to example 2. in example 2, I want this left fraction to work with to equal the right fraction. And again, like I said, you always start with your left and manipulate your left. You'll never ever manipulate your right. It's always going to be just the left side. All right, so let's look to this and see what we can do. I have everything's to the first power, so it means I have to use one of my very first basic trig identities. I can't use the cosine squareds or the sine squareds. I've got to use my basic ones. And on the right, everything is just going to eventually equal a sine y. Okay. Well, the top of the fraction 1 minus sine y, I know that I can at least rewrite cosecant in terms of sine. Cosecant is 1 over sine, and then minus 1. Okay, so we're kind of getting started. Everything's now in terms of sine, which is great. And at this point, I kind of want to get rid of the complexity here. I've got a fraction inside of my big overall fraction. And the way to get rid of it is to multiply by whatever's in the denominator. So I'm going to multiply this denominator here by sine y, and this top by sine y. And I can do that because technically all I'm doing is multiplying this fraction by just a fancy looking 1. Okay. So going across the top, I'm not going to pull in that sine y up there on the top. I'm just going to leave it as sine y times 1 minus sine y. Okay. And then down here in the bottom, if I multiply sine y times 1 over sine y, you just get 1. Sine y times a negative 1 is a minus sine y. And look right here. This 1 minus sine y, which is a factor of the top, cancels with the bottom, and all I get is sine y, which is what I wanted the right side to be. Okay? So I guess in a nutshell is with what you're starting out with over here, if it's not any squares, sometimes you won't make any of the hard or the more difficult substitutions. You're just going to do a simple substitution, like rewriting cosecant as 1 over sine. And then from there, it's really just a bunch of algebra to get it to be your answer. Okay, so this next example, I have cosecant cubed x minus 8. I've got cotangent squared x plus cosecant minus 5. Everything over here on the right looks like a bunch of cosecants. So I'm probably going to replace that with an identity, and everything else I'm going to leave that. So let's start with just that first step. So cosecant squared x minus 8 over, well, what is that identity that involves both cosecant and cotangent? Coming over here to the right, we can just write it out. Is cotangent squared x plus 1 is cosecant squared x. So in other words, rearranging this, cotangent squared x is cosecant squared x minus 1. So this is what I'm going to replace in for that cotangent there in the denominator. Okay. So instead of cotangent squared, I'm going to go cosecant squared x minus 1, and then plus cosecant x minus 5. Okay. Let's kind of rearrange this in the denominator. And I just realized that I wrote it as a squared up there, and it should be a 3 right there. But cosecant cubed x minus 8 over cosecant squared x plus cosecant x minus 6. Alright, now from there, it looks we're heading in the right direction. We've got everything in terms of cosecants at least. And so at this step, everything's been replaced. I don't want to do any more identities, any more substitutions like that. All I want to do is algebra. And the only way I can kind of work with this is probably let's try factoring. That's the first thing that kind of pops in my head is to try factoring. Because everything over here on this right side of this equation is in either squared or the first powers. So if I'm going to try to bring down the power of 3 up here in the numerator, the only way that it can bring it down is to factor it. And if we look closely, what we really have is a difference of cubes. What's being cubed in the first term is cosecant x. What's being cubed in the second is a 2. So that formula says just write down in the first parentheses what's being cubed in each term. Then we're going to square the first thing, opposite sign, multiply them together, always positive, and the last thing squared. And the same thing here with the denominator. Let's see if we can factor this. Since it's just a quadratic, both parentheses are going to lead with just cosecant x. And then the factors of negative 6 that add up to positive 1 look like a plus 3 and a minus 2. Well, we got common factors here, the cosecant x minus 2 and the cosecant x minus 2. And if we write what's left over, we have cosecant squared x plus 2 cosecant x plus 4 all over cosecant x plus 3. Looking up above to that right side, looks like we got our answer. Okay? So again, just kind of coming back to this one step, I think this whole problem was built on the fact of, I put it in here was to show you again how to practice factoring with the difference of cubes. What's being cubed here is a cosecant x. What's being cubed there is a 2. So there's cosecant x and 2. And then you do your same sign, opposite sign, always positive. Square what was in the first, multiply them together, and square the back.